Well, it's very exciting for me to be here because I grew up 2 blocks away, and my mother was the mayor of Menlo Park. And when I was about 10 years old, I used to ride my bike through here. It's certainly cleaned up since those Quonset huts and leftover World War II temporary buildings you guys used to work in here. But so I have to tell you, it's a very great fondness that I return. And I've already had somebody ask me to do this when I was out in the hallway here. And they're used to listening to me out of the dashboard of my car, and they asked me if I would do the open for them to the show. So I'm going to do it for everybody now. From San Francisco, I'm Moira Gunn, and this is Tech Nation. Now, it's a little unfortunate that, we started now because we actually, the moment we all met here, immediately we started this conversation and we're all interacting, and it's like, so we're just continuing it. And so with that, what we thought we'd do is just to start out, we'll eventually get to questions from the audience, but we'll start out, and first of all, Bruce, if you could give us some sort of first impressions, when you're about this topic.
Well, thanks. It's a pleasure to be here. I've been working pretty hard on this issue for 25 years, and I think things have only gotten worse, so I'm not sure that you want to hear from me. But my bottom line, I guess, is that science education in the United States today is a disaster. It's gotten worse since I first got involved. A major part of the blame is the No Child Left Behind law, which many of you know about. Basically, it was a good idea, I think, in theory, but in practice it didn't work. Basically, that we will hold students and teachers and schools accountable by testing them every year and have severe penalties for failing schools. We will make sure that we pay attention to all different groups of students, so no child will be left behind. A big emphasis on the poorest performing kids, getting them up to standards. The unintended consequence was terrible for science education. First of all, most of the testing and most of the focus was on mathematics and literacy. In San Francisco, my favorite science teachers, many of them, I ran a National Science Foundation sponsored, funded program called City Science for 5 years in the late 80s and early 90s. And we had something really good going. We had wonderful inquiry-based science education. I'll talk about that in a second. But many of my star teachers would tell me that, I can't teach science anymore. My principal wants us to focus on what's tested, which is reading and math. There is some science testing, and that doesn't help either, because first of all, in the wonderful state of California, we have the California State Science Standards, which were supposed to be modeled after something I worked very hard on in the early 1993 and 1995, the National Science Education Standards. But in their wisdom, this state adopted standards which were greatly in conflict with what the Academy had said science teaching should be about. My interpretation is that they had no confidence at all in teachers. They wanted to hold teachers accountable by giving them details of what students had to be tested on every year. I know, because I was involved from afar in the debate, the feeling was that we weren't demanding hard enough things at the national level. We, for example, said, after a lot of work at the national level by experts, that kids in 7th grade should not have to learn the names of the parts of the cell. I'm a cell biologist, so I'm bringing this. So I know many parts of the cell. but that was one of the things that was criticized. They need to know the parts. They need to know the names of the parts. What we said, we need in the national documents, you have to understand what a cell is, and the names get in the way of understanding if you're doing it at that level. So I have grandchildren in the public schools. They have to memorize 12 different parts of the cell. And there's no room in any of these books, or the teacher has no time, and the kids are not really ready to really understand what these parts do. So they memorize things, sentences like, how many of you know what the endoplasmic reticulum is? Okay.
I'm impressed.
I didn't learn about the endoplasmic reticulum until I was in graduate school. But anyway, It's very important, but it's really impossible to understand without knowing a lot about a cell. And so they memorize things like the endoplasmic reticulum stores and sorts materials. And then they have a little exam, and that's the other part of it. We don't not willing to pay enough for exams. We try to get cheap exams so we could test everybody for $1 a kid or something. And so these are tests that you could test by score by machine, and so they have to match what the endoplasmic reticulum, which of the 4 choices matches that definition. At any rate, the net result is kids hate science. I would hate it too if that was the kind of science that I had. And we need to really change dramatically what we're doing. It's so bad that I think we have a good chance of starting over. I like to tell my colleagues about, recently I was at Madison, Wisconsin, and a scientist mother told me what her 3rd grade child had recently come back and told her about science in school. I guess they must have the same kind of science teaching in Wisconsin that we have in California. He said, I get it. Now I understand science. It's just like spelling. You just have to memorize it, and it doesn't mean anything. It doesn't make any, no, it doesn't have to memorize, it doesn't make any sense. Okay, well, that's the way we teach it. So at any rate, when you go into 8th grade classes today, you find the kids are totally disenchanted. Science has become something they don't like. It's painful, it's not interesting, and it doesn't have to be that way. So I've been pushing a science magazine. I just want to wave this in. This is Science Magazine. It comes out every week. And this happens to be a special issue on education. We've had 3 of them. But I've been stressing that we need to redefine science education. It's gotten so far off track. Science education should not be about learning everything that the scientists have discovered, because, first of all, every year we discover so much more that it becomes more and more impossible to learn everything that we've discovered, even the important things. Instead, our focus has to be on teaching kids what science is by letting them experience it. And very recently, there's a new so-called common standards movement, reaction to the failure of the previous generation's standards movement, which stresses the practices of science, learning by actually doing to understand how to solve problems like a scientist, so you could think like a scientist. Important for everyone. If we do it, it will not only get many more kids interested in science and find those people who have talent and encourage them to be scientists or engineers, but it will also create a voting public that can think rationally and not be fooled by all the slogans that go around and try to fool us, whether it's in politics or over the internet, somebody trying to sell you something. So it makes a lot of sense to redefine science education. Let me just give you an example, a simple example of what kind of science education I'm talking about. When I left San Francisco to go to the academy full-time in 1993, official part of the curriculum, thanks to Ray Cortines, who had been the superintendent of schools, who really was a very wise and effective superintendent. The official part of the San Francisco science curriculum started in kindergarten, 5-year-olds. And the piece of the curriculum was the following. The kids, at the right time of year, when there's seeds on the ground, they were given white socks, and they were to walk around in the schoolyard under the trees and let the socks pick up seeds and dirt. And they come back.
Can afford that science experiment.
Yeah, this is good science education doesn't have to be expensive. In fact, anyway, so they come back in the classroom. They have a little forceps and a tiny little $3 microscope, a little plastic thing that they could look in as sort of a microscope. And they're to put each of the black specks off their sock into a numbered square, and then for each one they're supposed to look at the microscope on another piece of paper, draw a picture of what it looked like. And after they've done that, they're supposed to discuss which ones are seeds and which ones are dirt. And the teacher acts as a coach, so the teacher must not tell them the answer. So eventually some kid will just suggest that the regular shaped objects may be the seeds and the irregular ones maybe the dirt. And then the class discusses that and see whether they think that's a reasonable idea. And then eventually, of course, the teacher will coach them into thinking it's a reasonable idea. And then that's our hypothesis. Then the teacher says, well, how do we test this? And she doesn't tell them how to test. And eventually some kid will say, well, we could plant the two kinds of specks and see if only the ones that we think are seeds grow out plants. And so the class then does that. And this is actually a piece of curriculum that was developed in Boston by a very good group that develops science curriculum. And the fact is the United States, ever since Sputnik, has the very best inquiry-based science education anywhere in the world. But unfortunately, it's used more abroad. My friends in the French Academy of Sciences have taken this and other pieces of U.S. curriculum, and now 40% of the kids in France are doing this because they have a national system, unlike our chaotic system. At any rate, my last thing I want to say is that we could make, what I learned in all this painful experience since working on the standards and seeing how they did not work is it doesn't really make any difference what kind of standards you have unless you have the right kind of tests. What really matters is what adults test children on really defines for them what they should learn and what science education means. And the biggest challenge we have now, and I think it's a really critical national challenge, is to mobilize the very best people in this country, and there are many good people in this country, bringing them together, and it's a matter of national service to work to produce outstanding science assessments that will drive good teaching and good learning. And of course, we won't get it exactly right. We never get anything this complicated exactly right. So we have to couple that to a research process that says, once we put the best guess at what these assessments are, once we put them out there, what are they actually doing to schools? Is it causing teachers to teach the way we want them to teach? Is it causing students to learn the way we want them to learn? At any rate, this is a moment in time when this is critical because No Child Left Behind is being reauthorized. There's a lot of rethinking about that. The state governors had decided that this states' rights for science standards doesn't make sense, or math standards and reading standards. So now there's this common standards movement. Math and reading went first, but now science standards are coming. 26 states, including California, have signed on in principle for these so-called common standards. But none of this will work unless we have the right kind of tests. So now that we have sort of a set of major states, a large fraction of the United States is going to do the same kind of science teaching and learning, we need a national effort to produce outstanding assessments.